Capacitance of a capacitor with dielectric. In the previous case, we have seen that in the case of a capacitor, if charge is given to one of the plates plus Q, equal and opposite charge is induced on the other plate minus Q. Because of these two charges, electric field between the plates is E equal to sigma by epsilon naught, and capacitance of the capacitor is epsilon naught A by D, where A is area of each plate, D is distance between the plates, small d. Now, the space between the plates is filled with suitable dielectric medium. Let this be the dielectric medium, like paper, glass, mica, water. It should be an insulator, that's all. Okay. If this is a dielectric medium, when charge is given to one plate, opposite charge is induced because the second plate is connected to ground. At the same time, the molecules in the dielectric are polarized. Because of the polarization, dipole moment is induced. Observe, negative charge in the dipoles is closer to positive plate. So effect of positive plate is decreased by this negative as well as this negative. If sigma is surface charge density on the plate, then sigma p is the polarized charge density. Sigma is applied, charge by area. Sigma p is this polarized charge density. If it's a rectangle like this, try to visualize, then area of this plate matters. Charge on this by area of this, that is sigma p. So what is the net effect means? Sigma minus sigma p. So net charge density is sigma minus sigma p. Here you have to understand one thing, that this net charge density is directly proportional to the applied charge density. So the leftover charge density is directly proportional to this sigma. Why there is sigma p? Sigma p is polarized charge density, that's because of this applied sigma. What is the net means? Sigma minus sigma p, which is proportional to the applied, which is sigma. Suppose applied is 10 unit, induced is 4 unit, minus 4. So resultant is 6. Now applied is increased to 20 unit. Then the sigma p may become 6. So 20 minus 6 equal to 14. See, this number increases with the increase in this applied. This is the meaning. Sigma minus sigma p is proportional to sigma. Net effect is directly proportional to the applied. So using these concepts, we have to derive an expression for capacitance of a capacitor with dielectric. Consider a parallel plate capacitor. Let A be the area of each plate and D be the distance between the plates. One of the plates is connected to ground and the other plate is charged. Due to induction, equal and opposite charge is induced on the plate which is connected to ground. This we have seen in the last case, last derivation also. Means if this is a capacitor, second plate is connected to ground. If charge is given to one plate, then equal and opposite charge is induced on that plate which is connected to ground. Electric field between the plates when there is air or vacuum is E equal to sigma by epsilon naught. This is E naught, which represents air or vacuum, and surface charge density on each plate is sigma. And capacitance of the capacitor is C equal to epsilon naught A by D. This is capacitance in air or vacuum, therefore let us denote it by C naught. Consider a dielectric inserted between the plates, fully occupying the intervening region. So in this case, if this is a capacitor, one of the plates is connected to ground, there is a dielectric medium, suitable dielectric medium between the plates like this. If charge is given to one plate, equal and opposite charge is induced. Corresponding charge density is sigma, and molecules are polarized, which give rise to some charge on that face which is closer to positive, and that charge density is sigma p, polarized charge density. And this side plus. The dielectric is polarized by the electric field. Let sigma p be the polarized charge density. The net charge density is plus or minus sigma minus sigma p, the difference of these two. Therefore, the electric field between the plates is sigma minus sigma p by epsilon naught. The resultant charge density matters. Here sigma by epsilon naught, here sigma minus sigma p by epsilon naught. This is the difference when a dielectric medium is inserted. The net charge density is directly proportional to charge density on each plate. Means sigma minus sigma p is proportional to charge density sigma, or sigma minus sigma p is equal to 1 by k. So this 1 by k is the proportionality constant into sigma. Students, usually we consider k as proportionality constant. Here this is the proportionality constant. Constant of proportionality, and this k is called dielectric constant. Therefore, this electric field becomes electric field between the plates equal to sigma by k in place of sigma minus sigma p into 1 by epsilon naught. 1 by epsilon naught. As usual, electric field is minus dV by dr, or electric field equal to potential difference by distance between the plates, and sigma equal to charge by area of each plate. Let this be equation 1. Let us substitute these two equations in equation 1. Above two equations means these two equations in equation 1. In place of electric field, V by D. V by D equal to, in place of sigma, Q by A, there is constant of proportional, there is constant, dielectric constant, into 1 by epsilon naught, or Q by V equal to epsilon naught K A by D. Capacitance of a capacitor is C equal to Q by V equal to epsilon naught K A by D, or C is also equal to just epsilon A by D. Where epsilon equal to epsilon naught into K, dielectric constant. Sometimes dielectric constant is also denoted by epsilon R, also called relative permittivity of the medium. So this is the expression for capacitance of a parallel plate capacitor with dielectric medium. Capacitance of a parallel plate capacitor with air or vacuum is C air equal to epsilon naught A by D. Capacitance of a parallel plate capacitor with dielectric medium is capacitance with medium equal to epsilon naught K A by D. Now capacitance in medium, capacitance with air. Capacitance of a capacitor with medium, dielectric medium, by capacitance of a capacitor with air equal to K. Therefore, dielectric constant is the ratio of capacitance of a capacitor with dielectric medium to the capacitance of the same capacitor with air or vacuum. Dielectric constant is the ratio of capacitance of the capacitor with dielectric, that is numerator, to capacitance of the same capacitor with air or vacuum between the plates. So this dielectric constant or relative permittivity is also ratio of force between two charges in air by force between same two charges separated by same distance in medium, also equal to ratio of electric field in air by electric field in medium, equal to ratio of potential in air by potential in medium. But K is capacitance in medium by capacitance in air, and always K is greater than 1. If K is greater than 1 means numerator is always greater than denominator. Second note, consider Q equal to C into V. If Q equal to 1 coulomb and V is 1 volt, implies C equal to 1 farad. See, if Q is 1, V is 1, then C equal to 1 farad. Capacitance of a capacitor is said to be 1 farad if addition of 1 coulomb of charge increases the potential by 1 volt. We can also say increases the potential difference by 1 volt. Potential difference means potential difference between the plates. Consider Q equal to CV or C equal to Q by V. Unit of Q is coulomb, unit of potential difference is volt, that is joule per coulomb. So this becomes coulomb square by joule. So let us write dimensional formula. For coulomb square, AT, its square, because coulomb is not fundamental physical quantity. Express coulomb in terms of current, ampere time. So current equal to charge by time, charge equal to current into time. Current is ampere, time is T, its square. Joule is mL2 T minus 2. After simplification, we get m minus 1, m goes to numerator, becomes minus 1, L minus 2, T minus 2 goes to numerator, becomes T2, there is already T2, therefore T4 A2. So this is the dimensional formula. Most probable questions. Define dielectric constant in terms of capacitance of capacitors. For 1 mark, you have to write this statement. So dielectric constant is capacitance of a capacitor with medium to capacitance of a capacitor with air or vacuum. So you have to write this statement. Mention an expression for capacitance of a capacitor with dielectric medium. Just the expression. So C equal to epsilon naught A K by D. with dielectric medium. Students, I insist you to write each and every term. Okay, so please write where epsilon naught is absolute permittivity of free space, A is area of each plate, K dielectric constant, and D distance between the plates. What happens to capacitance of a capacitor when a medium of higher dielectric constant is inserted between the plates? Since capacitance is directly proportional to K, with the increase in K, C also increases. Or you have to write that capacitance increases for 1 mark. Capacitance of air core capacitor is C. What is the capacitance when area of each plate is doubled, distance between the plates is halved, and electric medium of constant 4 is filled between the plates? If this question is asked for 1 mark, then C dash equal to 16 times C. If you write the answer, that's enough. If the same question is asked for 2 marks, then C equal to epsilon naught A by D. This is with air. With air, capacitance is C. Now C dash equal to epsilon naught K A dash by D dash equal to this epsilon naught. K is 4. K is 4. 4. A dash is 2A. Area of each plate is doubled. 2A epsilon naught by D dash is distance between the plates is halved. So it is D by 2. Therefore C dash becomes 16 times epsilon naught A by D, or 16 times C. For 2 marks, you have to show few steps. At the end, you will get 16 times C. So this could be for 1 or 2 marks, conceptual type. Derive an expression for capacitance of a parallel plate capacitor with dielectric medium. This can be asked for 3 or 4 or 5.